Here are 50 detailed and informative real-world problem-solving interview questions and answers of Amazon Redshift, useful for preparing for a technical interview. 1. Problem. How do you optimize query performance in a Redshift data warehouse? Answer. To optimize query performance in Amazon Redshift, ensure that you choose sort keys that align with your most common queries to speed up data retrieval. Also, use distribution keys to distribute data across nodes evenly, which helps in parallel processing and reduces query times. Compression encodings should be appropriately applied to reduce storage space and I/O overhead. Regularly analyze and vacuum your tables to maintain data distribution and reclaim space from deleted rows. 2. Problem. What steps would you take to design a Redshift schema for a high-performance application? Answer. When designing a schema for high performance in Redshift, consider using a star or snowflake schema for simplifying queries and improving performance. Select the distribution style key, all, or even based on the table size and query patterns. Choose sort keys that will help in query optimizations, typically fields that are frequently used in join, WHERE, or order by clauses. Additionally, apply column compression encodings to minimize disk I/O. 3. Problem. Your Redshift cluster is experiencing slow write speeds. What could be causing this, and how would you address it? Answer. Slow write speeds can be caused by several factors, including network issues, the configuration of the Redshift cluster, or inefficient data distribution across the cluster. To address this, check the network bandwidth and latency first. Review the distribution keys to ensure data is evenly spread across all nodes, minimizing bottlenecks. Consider increasing the size or number of nodes in the cluster to improve throughput. 4. Problem. Describe how you would configure WLM, workload management, settings in Redshift for managing different user groups' query performance. Answer. Configuring workload management WLM in Redshift involves creating different queues for user groups and assigning memory and concurrency limits to these queues. You can set up WLM to prioritize critical queries or to isolate heavy queries that might interfere with regular operations. Utilize query monitoring rules to automatically hop queries between queues based on runtime or other metrics to manage performance dynamically. 5. Problem. How do you handle data security in Amazon Redshift, particularly when dealing with sensitive information? Answer. Data security in Amazon Redshift can be managed by using a combination of encryption, network isolation, and access control. Enable encryption in transit using SSL and at rest using KMS or HSM. Restrict cluster access by setting up VPCs and using security groups wisely. Implement IAM policies and roles for controlled access to the Redshift cluster, and use column-level security or redaction to further restrict sensitive data access. 6. Problem. What approach would you take to diagnose and solve concurrency issues in a busy Redshift cluster? Answer. To diagnose and resolve concurrency issues in Redshift, first monitor the system for queries that are waiting in queues using system views like STL_WLM_QUERY. Adjust the WLM configurations, increasing the number of slots or redistributing them among different queues. Consider implementing short query acceleration to prioritize quick-running queries, ensuring they are not stuck behind long-running operations. 7. Problem. Explain how you would use the copy command in Redshift for efficient data loading. Answer. The copy command is optimized for loading large volumes of data into Redshift from S3, Dynamod, or other supported sources. To use copy efficiently, make sure your data files are split into multiple chunks that can be loaded in parallel across the cluster's nodes. Compress the data files using a supported format like gzip to reduce data transfer time. Also, ensure the data distribution style and sort keys are appropriately set up before loading to enhance performance. 8. Problem. What would you recommend for disaster recovery solutions in Amazon Redshift? Answer. For disaster recovery in Amazon Redshift, ensure that automated snapshots are enabled and configure the snapshot schedule according to your recovery point objectives, PO. Consider cross-region snapshot copy features for geographical redundancy. Also, regularly test your recovery procedures by restoring snapshots into new clusters to ensure that you can reliably recover data in case of a disaster. 9. Problem. How do you scale an Amazon Redshift cluster efficiently without downtime? Answer. To scale an Amazon Redshift cluster efficiently, use the Elastic Resize feature for quickly adding or removing nodes based on demand. For a more permanent solution, consider resizing to a different node type or a larger configuration, which can be done with minimal downtime using the classic resize approach. Always monitor performance and query load to determine the right time and size for scaling. 10. Problem. What techniques would you employ to reduce costs while maintaining performance in Redshift? Answer. To reduce costs in Redshift while maintaining performance, focus on optimizing your queries and data storage. Use compression to reduce storage costs, and carefully select sort keys and distribution styles to enhance query performance, which can reduce the need for larger, more expensive clusters. Consider using reserved instances for long-term cost savings. Additionally, offload historical data to cheaper storage solutions like S3 using Redshift Spectrum when appropriate. 11. Problem. You've noticed that certain queries are performing poorly in your Redshift cluster. How would you go about identifying the root cause of these performance issues? Answer. To identify the root cause of poor query performance in Redshift, I would start by analyzing query execution plans using Explain. This helps identify inefficient query execution paths, such as full table scans or unnecessary joins. I would also check system views, like svv_table_FO and svv_discussage, to ensure that tables are properly distributed and sorted. Monitoring system metrics like CPU and disk usage can also provide insights into potential bottlenecks. 12. Problem. Your Redshift cluster is running out of storage space. What steps would you take to address this issue? Answer. To address storage space issues in Redshift, I would first identify tables or columns consuming the most storage using system views like svv_table_info. I would then consider options such as enabling compression for tables with high storage usage, or archiving and offloading historical data to S3 using Redshift Spectrum. If necessary, I would also resize the cluster to increase storage capacity. 13. Problem. Explain how you would optimize Redshift performance for complex analytical queries involving multiple joins and aggregations. Answer. To optimize Redshift performance for complex analytical queries, I would ensure that tables are properly distributed and sorted based on join and aggregation keys. I would use interleave sort keys for columns frequently used in multiple joins. Additionally, I would consider denormalizing tables or creating materialized views to pre-compute aggregations and reduce query complexity. Monitoring and tuning query queues and memory allocation can also help improve performance. 14. Problem. Your Redshift cluster is experiencing intermittent network connectivity issues. How would you troubleshoot and resolve this issue? Answer. To troubleshoot and resolve network connectivity issues in Redshift, I would first check the cluster's network settings and security groups to ensure they are configured correctly. I would also monitor network traffic using CloudWatch metrics and VPC flow logs to identify any anomalies or bottlenecks. If necessary, I would work with AWS support to investigate underlying infrastructure issues. 15. Problem. Describe the process for optimizing ETL extract, transform, load processes in Redshift. Answer. Optimizing ETL processes in Redshift involves several steps. First, I would ensure that data is loaded in parallel using the copy command, and that compression is applied to reduce storage and improve performance. I would then use best practices for transforming data within Redshift, such as using SQL functions and window functions efficiently. Finally, I would schedule ETL jobs during off-peak hours to minimize impact on cluster performance. 16. Problem. How would you design a data warehouse schema for a Redshift cluster, supporting both OLAP online analytical processing and OLTP online transaction processing workloads? Answer. For a Redshift cluster supporting both OLAP and OLTP workloads, I would consider a hybrid schema design. This might involve using a star schema for OLAP queries, with fact and dimension tables optimized for analytical reporting. For OLTP workloads, I would use a normalized schema to minimize redundancy and ensure data integrity. I would also consider implementing materialized views or denormalized tables to improve performance for OLAP queries. 17. Problem. Your Redshift cluster is experiencing high CPU utilization during peak usage hours. How would you address this issue? Answer. To address high CPU utilization in Redshift during peak hours, I would first identify the queries or workloads causing the spike using system views like SVL_QUERY_report. I would then optimize these queries by analyzing query execution plans and making adjustments to improve performance. Additionally, I would consider scaling up the cluster by adding more nodes or upgrading to a larger node type to handle increased workload demands. 18. Problem. Explain the concept of query optimization in Redshift and describe techniques for improving query performance. Answer. Query optimization in Redshift involves various techniques for improving query performance. This includes selecting appropriate sort keys and distribution styles, optimizing join and aggregation strategies, and minimizing data movement across nodes. Other techniques include using column compression, leveraging zone maps for partition pruning, and caching frequently accessed data. Regularly monitoring and tuning query performance is also essential for ongoing optimization. 19. Problem. Your Redshift cluster is experiencing a surge in query concurrency, leading to degraded performance. How would you manage concurrency to maintain optimal performance? Answer. To manage concurrency in Redshift and maintain optimal performance, I would adjust the workload management WLM configuration to allocate more memory and slots to critical queries or user groups. I would also prioritize short-running queries using short query acceleration and consider limiting the concurrency of long-running queries to prevent resource contention. Monitoring system metrics and adjusting WLM settings dynamically based on workload patterns is key to managing concurrency effectively. 20. Problem. Describe the process for upgrading the version of Redshift in your cluster while minimizing downtime and ensuring data integrity. Answer. Upgrading the version of Redshift in a cluster involves several steps to minimize downtime and ensure data integrity. This includes creating a snapshot of the existing cluster for backup purposes, launching a new cluster with the desired Redshift version, and restoring data from the snapshot to the new cluster. During the migration, I would redirect traffic to the new cluster and monitor performance to ensure that the upgrade was successful. Conducting a thorough testing phase before the full migration is also crucial to identify and resolve any issues. 21. Problem. How can you ensure data security and compliance in a Redshift data warehouse environment? Answer. Ensuring data security and compliance in Redshift involves implementing multiple layers of security. This includes configuring network and firewall settings to restrict access to the cluster, using IAM roles and policies to control access to data, and encrypting data at rest and in transit using AWS Key Management Service (KMS), regular audits, and compliance checks using tools like AWS Config and AWS CloudTrail, are also essential to monitor and enforce security policies. 22. Problem. How would you handle disaster recovery planning for your Redshift cluster? Answer. Disaster recovery planning for a Redshift cluster involves creating and regularly updating snapshots for backup, implementing a cross-region snapshot copy to ensure data is available in multiple geographic locations, and developing a recovery plan that includes procedures for restoring from a snapshot in the event of a disaster. Regularly testing the recovery plan to ensure it can be executed quickly and effectively is crucial for successful disaster recovery. 23. Problem. What strategies would you employ to optimize the cost of operating a Redshift cluster while still meeting performance requirements? Answer. Optimizing the cost of operating a Redshift cluster involves several strategies. First, I would monitor and analyze usage patterns to right-size the cluster, ensuring it is scaled appropriately for current and projected workloads. I would also consider using reserved instances for long-term cost savings, and automatically scaling the cluster up or down based on demand using Redshift's elasticity features. Additionally, implementing query optimization techniques to reduce resource consumption and improve query performance can also help manage costs. 24. Problem. How can you use Redshift Spectrum to enhance the capabilities of your Redshift cluster? Answer. Redshift Spectrum allows querying data stored in S3 directly from Redshift, enabling a lakehouse architecture that combines the benefits of data lakes and data warehouses. To use Spectrum effectively, I would set up external tables in Redshift that reference S3 data, ensuring that the S3 data is organized and partitioned effectively to optimize query performance. This setup enables seamless querying across both on-cluster and off-cluster data, enhancing analytical capabilities without requiring additional storage on the Redshift cluster itself. 25. Problem. You need to migrate a large amount of data from an on-premises database to Redshift. Describe the steps you would take to ensure a successful migration. Answer. For a successful data migration from an on-premises database to Redshift, I would start by assessing the data structures and requirements to plan the migration strategy. This includes choosing the appropriate tools, such as AWS Database Migration Service (DMS), for continuous replication, or using bulk data loading techniques like the copy command. I would ensure data integrity by performing comprehensive testing and validation after the migration. Additionally, I would optimize the data schema in Redshift for performance and configure ongoing replication if the on-premises database needs to stay in sync. 26. Problem. Describe how you would use machine learning with Redshift to gain deeper insights from your data. Answer. Integrating machine learning with Redshift involves using AWS services like Redshift ML. This service allows creating, training, and deploying machine learning models directly within Redshift using SQL commands. To implement this, I would identify use cases suitable for machine learning, such as predictive analytics or customer segmentation, and prepare the data accordingly. After deploying the models, I would make predictions and integrate them into business intelligence tools for enhanced decision-making. 27. Problem. What are the best practices for monitoring and maintaining the health of a Redshift cluster? Answer. Best practices for monitoring and maintaining the health of a Redshift cluster include setting up monitoring through Amazon CloudWatch to track metrics such as CPU utilization, storage usage, and query performance. Regularly reviewing these metrics helps identify trends and potential issues. I would also implement logging and alerting with AWS CloudTrail and SNS to receive notifications of critical events. Additionally, routine maintenance tasks like analyzing and vacuuming tables to reclaim space and optimize query performance are crucial. 28. Problem. How would you handle version control and change management in a Redshift environment? Answer. Handling version control and change management in Redshift involves implementing a structured process for managing changes to database schemas and ETL scripts. This includes using version control systems like Git to track changes and maintain a history of modifications. I would also set up a staging or development environment to test changes before applying them to the production cluster. Additionally, using automated deployment tools and CI/CD pipelines can help streamline the change management process. 29. Problem. Explain how you would use columnar storage and compression to improve query performance in Redshift. Answer. Redshift uses columnar storage, which allows for efficient data storage and retrieval. By storing data column-wise rather than row-wise. To improve query performance, I would leverage columnar storage by selecting appropriate sort keys and distribution styles for tables, and using compression techniques like run-length encoding and delta encoding to reduce storage footprint. This minimizes I/O operations during query execution and speeds up data retrieval. 30. Problem. Your organization wants to implement a disaster recovery strategy for its Redshift cluster. What options would you consider? And how would you implement them? Answer. Implementing a disaster recovery strategy for a Redshift cluster involves several options, including cross-region snapshots, automated backups, and replication to standby clusters. I would consider setting up cross-region snapshots to create backups in multiple geographic locations, ensuring data resilience. Additionally, configuring automated backups with a retention period ensures that data is regularly backed up for point-in-time recovery. For real-time replication, I would use features like cross-region replication or Redshift Spectrum to maintain synchronized copies of data in different regions. 31. Problem. Your Redshift cluster is experiencing high disk usage, impacting query performance. How would you identify and address disk space issues? Answer. I would start by analyzing disk space usage using system tables like SDV_blocklist and SDV_TBLPERM, identifying tables with significant disk space consumption. Then, I would optimize storage by vacuuming and reindexing tables, compressing data, and redistributing data across nodes. Additionally, archiving or deleting unnecessary data can free up disk space and improve performance. 32. Problem. You need to load data from multiple sources into Redshift. How would you design an ETL process to handle this data ingestion efficiently? Answer. I would design an ETL process using tools like Glue or Apache Airflow to orchestrate data extraction, transformation, and loading tasks. Utilizing Redshift's copy command for bulk data loading and optimizing data formats and compression can improve ingestion performance. Parallelizing data loading tasks and leveraging data pipelines for automation ensure efficient and scalable data ingestion. 33. Problem. Your team is migrating from an existing data warehouse to Redshift. How would you ensure a smooth transition without disrupting business operations? Answer. I would plan the migration carefully, starting with assessing the existing data warehouse schema and data dependencies, creating a migration roadmap with clear milestones and conducting thorough testing at each stage minimizes risks. Utilizing tools like AWS Database, Migration Service, DMS, or custom ETL pipelines ensures data consistency and integrity during the migration process. Continuous monitoring and communication with stakeholders help address any issues promptly. 34. Problem. Describe the process of optimizing query performance in Redshift. Answer. Optimizing query performance in Redshift involves several steps. This includes analyzing query execution plans using Explain, identifying inefficient query patterns, and optimizing SQL queries accordingly. I would utilize distribution styles and sort keys to optimize data distribution and retrieval. Additionally, creating appropriate table statistics and using query caching techniques can further improve performance. 35. Problem. Your organization needs to integrate Redshift with external data sources for analytics. How would you design a data integration strategy? Answer: I would design a data integration strategy using OR's glue or custom ETL pipelines to extract data from external sources like S3, RDS, or Dynamod and load it into Redshift. Utilizing Redshift Spectrum for querying external data directly from S3 can reduce data movement and latency. Implementing change data capture (CDC) mechanisms for real-time data synchronization ensures data freshness and accuracy in analytics. 36. Problem: your Redshift cluster is experiencing query concurrency issues during peak usage periods. How would you optimize query concurrency and resource utilization? Answer: optimizing query concurrency in Redshift involves configuring WLM, workload management, queues and query priorities to allocate resources effectively. I would adjust concurrency scaling settings to automatically add or remove compute nodes based on workload demands. Utilizing workload management features like query monitoring and performance tuning helps identify and resolve bottlenecks, ensuring smooth query execution even under high concurrency. 37. Problem: explain how Redshift handles data distribution and sorting, and how you would choose appropriate distribution and sort keys for tables. Answer: Redshift distributes data across compute nodes based on the distribution style chosen for tables, such as key, all, or even. Choosing appropriate distribution and sort keys depends on query patterns and access patterns. I would select distribution keys based on join and filter predicates to minimize data movement during query execution. Sort keys are chosen to order data within blocks, improving query performance for range-based queries and aggregations. 38. Problem: your organization wants to implement data retention policies for compliance and cost optimization. How would you design a data archiving strategy in Redshift? Answer: designing a data archiving strategy involves identifying data retention requirements and access patterns. I would partition tables based on time and archive historical data to cheaper storage tiers like S3 Glacier. Implementing table partitioning and lifecycle policies in Redshift Spectrum allows seamless access to archived data while reducing storage costs. Regularly purging expired data and automating archiving tasks ensure compliance with retention policies. 39. Problem: your Redshift cluster is experiencing intermittent network connectivity issues. How would you troubleshoot and resolve network-related issues? Answer: I would start by checking network configuration settings, such as VPC settings, security groups, and subnet routing tables, to ensure proper connectivity. Analyzing CloudWatch metrics for network throughput and latency helps identify performance bottlenecks. Verifying DNS resolution and network ACLs, and conducting network tests using tools like Ping and Traceroute can pinpoint network issues and guide troubleshooting steps. 40. Problem: describe the process of monitoring and optimizing Redshift storage utilization. Answer: monitoring and optimizing Redshift storage utilization involves regularly analyzing disk space usage and identifying storage-intensive tables or queries. I would use system tables like SVV_diskUsage and SDV_TBL_PERM to monitor storage consumption. Implementing automated alerts for high disk space usage and performing routine maintenance tasks like vacuuming and reindexing tables ensure efficient storage utilization. Additionally, optimizing data compression and purging obsolete data help manage storage costs effectively. 41. Problem: your organization wants to implement data encryption at rest in Redshift to enhance security. How would you configure encryption for data stored in Redshift? Answer: configuring encryption at rest in Redshift involves enabling the AWS Key Management Service (KMS) for Redshift clusters and selecting an encryption key. I would enable encryption during cluster creation or modify existing clusters to use encryption. Implementing granular IAM policies for KMS key management ensures proper access control. Regularly rotating encryption keys and monitoring encryption status ensure data security compliance. 42. Problem: your team needs to analyze query performance and identify slow-running queries in Redshift. How would you approach query performance analysis and optimization? Answer: I would start by analyzing query execution plans and performance metrics. Using native Redshift tools like SVL_QUERY_summary and SVL_QUERY_metrics. Identifying high CPU or high I/O queries and optimizing SQL queries through indexing. Data distribution and query rewriting improves performance. Utilizing query profiling and explain plans helps understand query execution paths and optimize resource allocation for better performance. 43. Problem: your organization wants to implement data replication for disaster recovery purposes in Redshift. How would you design and configure cross-region replication for Redshift clusters? Answer: designing cross-region replication involves creating a standby cluster in a different AWS region and configuring asynchronous replication between primary and standby clusters. Using AWS DMS database migration service or native Redshift features, configuring automatic failover policies and monitoring replication lag ensures data consistency and availability during failover scenarios. Implementing cross-region VPC peering or VPN connections ensures secure data replication across regions. 44. Problem: describe the process of optimizing Redshift performance for complex analytical queries involving joins and aggregations. Answer: optimizing performance for complex analytical queries in Redshift involves designing efficient data models, selecting appropriate distribution and sort keys, and creating appropriate table constraints and indexes. I would utilize techniques like denormalization, pre-aggregation, and materialized views to reduce query complexity and improve performance. Monitoring and tuning query execution plans and optimizing query parallelism settings further enhance performance for analytical workloads. 45. Problem: your team is experiencing high memory utilization on Redshift leader nodes, impacting cluster performance. How would you troubleshoot and optimize memory usage on Redshift clusters? Answer: troubleshooting high memory utilization on Redshift leader nodes involves analyzing memory-intensive queries and query queues using system views like STL_WLM_QUERY and STL_QUERY. I would optimize memory allocation settings like WLM_query_slot_count and max_memory_to_grant_% to balance memory usage across query queues. Identifying and tuning memory-intensive query patterns, such as sorts and joins, helps optimize memory utilization and improve overall cluster performance. 46. Problem: your organization wants to implement multi-factor authentication (MFA) for Redshift cluster access. How would you configure MFA for Redshift users? Answer: configuring MFA for Redshift involves enabling IAM-based authentication for Redshift clusters and configuring MFA for IAM users or groups. I would enable IAM roles for Redshift cluster access and enforce MFA requirements for IAM users through IAM policies. Configuring MFA devices or temporary session tokens for IAM users ensures secure authentication and access control to Redshift clusters. 47. Problem: your organization is planning to migrate data from an on-premises data warehouse to Redshift. How would you design and execute a data migration strategy for this migration? Answer: designing a data migration strategy involves assessing data volumes, schema complexity, and migration timelines. I would use AWS DMS or custom ETL pipelines to extract data from on-premises databases, transform data to match Redshift schema requirements, and load data into Redshift clusters, implementing data validation checks and performing incremental data loads, ensure data integrity and minimize downtime during migration. 48. Problem. Describe the process of optimizing Redshift performance for ad hoc analytical queries and interactive data exploration. Answer. Optimizing Redshift performance for ad hoc queries involves optimizing data distribution and sort keys, caching frequently accessed data, and tuning query concurrency settings. I would pre-compute and materialize intermediate results using temporary tables or CTS to improve query performance. Utilizing Redshift Spectrum for querying external data lakes and optimizing query planning and execution through query. Profiling further enhances performance for interactive data exploration. 49. Problem. Your organization wants to implement data masking and anonymization for sensitive data stored in Redshift. How would you design and implement data masking policies in Redshift? Answer. Designing data masking policies involves identifying sensitive columns and defining masking rules based on data privacy requirements. I would use Redshift user-defined functions, UDFs, or data masking libraries to implement masking logic for sensitive columns. Applying masking policies during data ingestion or through ETL pipelines ensures data confidentiality and compliance with data privacy regulations. Regularly auditing and validating masked data help maintain data integrity and security. 50. Problem. Your Redshift cluster is experiencing intermittent query timeouts and connection failures. How would you troubleshoot and resolve these connectivity issues? Answer. Troubleshooting connectivity issues in Redshift involves analyzing network configuration, security group settings, and VPC routing tables. I would check network ACLs and security group rules to ensure proper inbound and outbound traffic flow to Redshift clusters. Monitoring VPC flow logs and Redshift cluster event logs helps identify network-related errors and connection failures. Implementing VPC endpoint services and optimizing network bandwidth and latency further. IMP or OVS connectivity and reduces query timeouts. The above 50 questions and answers provide a comprehensive overview of real-world problem-solving scenarios in Amazon Redshift interviews, covering topics such as performance optimization, data migration, security implementation, and troubleshooting. These questions and answers offer insights into addressing various challenges encountered while working with Amazon Redshift. For more exciting tips, tricks, and more importantly for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more, that will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, 4 2 to 3 years experienced candidates, and 4 5 or above years experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.